Well, now we've covered the control of injected fluid as it passes through the injection wellhead and tubing and enters the injection zone. Are there any other potential pathways allowing saltwater migration from the injection zone into an underground source of drinking water? Well, to answer this question, let's look at the sequence of deposition in oil-producing areas. We typically find several layers of impermeable shale deposited between the injection zone and the freshwater sands near the surface. These layers provide additional barriers to the migration of produced water. Fluid injection immediately raises the injection zone's pressure in a circular area around the well. This pressure is the greatest in the area directly surrounding the well, dropping dramatically as the distance from the well increases because there are more places for the water to go. The highly pressurized fluid is contained in the injection zone by the impermeable layers. But let's imagine for a moment that the confining impermeable layers above the formation are not there to restrict the upward movement of the pressurized injection fluid. As you can see, the pressurized fluid could rise to a level shown with the arrows depending on the amount of reservoir pressure in each location. The greatest pressure and therefore the highest movement is in the area closest to the wellbore. Now, by connecting the arrowheads, we can create a simple representation of this reservoir's pressure profile. The part of the pressure profile where the reservoir pressure is high enough to move the injection fluids from the injection zone all the way up into an underground source of drinking water is referred to by regulators as the zone of endangering influence. The size of this endangering zone can be calculated. Its size is influenced by the volume of water injected, the volume and permeability of the formation, the pressure differential between the injection formation and the drinking water formation, and the difference in depth between the two formations. However, in reality, there is not only a confining layer, but many impermeable layers above the injection zone. For migration to occur, there must be some other avenue or conduit allowing fluid movement. For example, an improperly plugged abandoned well located here within the endangering zone creates the potential conduit for salt water to migrate into an underground freshwater source. However, even with an improperly plugged well in the area, other forces, in many cases naturally occurring, impede the vertical movement of injected fluid up the well and into freshwater sources. These forces include collapse of the wellbore, drilling mud or cement in the borehole, the presence of downhole equipment such as packers left in place, and the existence of other permeable formations located between the injection zone and freshwater sources to divert the flow of fluid.